We have this parallel circuit with one capacitor in this branch and this coil with resistance R in this branch. It's fed in sinusoidal voltage. We need to find the phase difference between the current and the source. So let's draw the phase diagram for the whole circuit. So for this branch, we'll have IC, which will be ahead of voltage by pi by 2. Then this is LR branch. In this branch we have L and R, so that is inductor dominated. So that will be the fourth quadrant. So ILR will be somewhere here. So if you take the vector sum of these two, you will get the final current I0, and he is asking what is this angle theta. So first we need the angle between IC and ILR. So this angle is 90. We need to find what is the angle phi so that we know the total angle. So ILR is making phi with the voltage, and what is that angle phi? For that we need to come to LR branch. So in LR branch you can see, so this time we are considering a series circuit, so we'll draw ILR along the x-axis and XR will be here. Sorry, this should be just R. Alright, so R will be here and XL will be here, and this ratio XL by R is V, that is the external voltage. So you can see here that current lags behind, so this is the ILR which lags behind voltage by phi, and that's what we have represented here. So ILR lags behind voltage by an angle phi. And what is this phi? So phi is tan inverse XL by R. So in the diagram you can see it like this. So why we have to make this diagram? Because we know when we will do the vector sum, we will need the angle of cos of phi we are going to need. So anyway, and also we need the magnitude of ILR. So that will be V by Z. So Z is root of R square plus omega square L square. So now let's do the vector sum here. Okay, IC is also not given to us, so IC is simply V by XC, that is V omega C. So we know ILR magnitude, we know IC magnitude, and we know the angle phi. So now we can calculate what is I0. So we can see I0 lags behind voltage by theta, and tan theta is given by this upon this. So this is ILR sin phi minus IC. So you can see in this parallelogram, this height will be this total height minus IC. So ILR sin phi minus IC divide by horizontal distance, that is ILR cos phi. So from here this becomes tan phi minus IC by ILR cos phi. So if you put the values of tan phi and cos phi from here and simplify, you are going to get this. So the phase difference is going to be this, our answer. And he has not asked, but if he wanted, if we wanted to find out I0, that will be simply IC square plus ILR whole square plus 2 IC ILR cos 90 plus phi. And again so cos 90 plus phi will become minus sin phi, and sin phi value you can get from here, and you can find the value of I0 also if they asked. So the phase difference will be this, and by this phase difference current is lagging behind voltage. Alright.